As a first step, I opened IntelliJ recent beta version, and I will create an empty new project. As I promised, there will be nothing. I will create every file by hand. I will call this KMP app. Okay, here's an empty app. The default KMP app IML file will be removed soon. I will start by adding a git ignore file. There are some files that we can add from Kotlin. For example, the .kotlin folder. We know that we are using Gradle for this, so we also add the .gradle. I recommend personally that we also add the .idea folder. There are people at JetBrains that would like you to include this. I personally always felt that in my projects, it's better to just exclude this unless I want to explicitly share one of the configuration files. Then I think it makes sense to ignore all build folders. We can then delete this IML file that was created for us. The next step would be the step that most people will be afraid of, which is creating a new empty Gradle project. This is where the wizard comes in most handy because it does the heavy lifting for you. But once you've done it several times, it starts getting easy and you start understanding what you're doing, and then it feels actually quite nice. For this, I recommend starting by just creating a settings.gradle.kts file. We should see that it allows us to import this project already. And what we want to do here, for the first few steps, do two things. First, we want to declare the repositories from where we can download some jars, some dependencies. And then we want to declare which modules we have in the project. So dependencies can be downloaded for plugins, and they can be downloaded for actual libraries that you compile and run against. Therefore, we have two blocks, like two DSL configuration blocks on where we can declare dependencies. Let's start by declaring the repositories that can be used for the plugins from Gradle plugins. I recommend starting with Maven Central first. Then we configure the repositories that we can use for regular dependencies. I again recommend starting with Maven Central first. And then I can start by saying that we want to have an app module using this include keyword. Once we have imported this project, IntelliJ will already add this Gradle folder here with the wrappers. I recommend just checking them into the VCS. Next, we define the plugins and the plugin versions. There are several ways on how we could tell Gradle which versions of plugins we want to use. There is some intricacies about how Gradle does its class loading. So the easiest way, the least error prone, whilst looking a little bit awkward, is to define the plugins and load them in the root build Gradle.kts and then just applying them on the subprojects. So we create the build Gradle.kts file on the root project. And we can declare the plugins that we want to load here. So let's resync so that IntelliJ gives us some meaningful insights of what we can do here and how we can work with this file. Now we can, for example, start by telling Gradle that we are interested in the Kotlin Multiplatform plugin by calling this Kotlin function here. Really, this is no magic. If we command click into this, and I'm not sure if we can index. Basically what this does is just a convenience function to prefix your module here with org.jetbrains.kotlin. So don't think there's a lot of magic going on by calling this Kotlin function. And now here, since we are not really interested in actually applying this plugin to the root project, we just want to load it. We call apply false. We did not specify yet what version we want. So therefore we can just say we are interested in Kotlin 2.00. Now let's also add the Android application plugin and see how this will work. So the Android application plugin lives under the ID com Android application. I would like to use the most recent released version as of the time of this recording. I again use apply false because I do not want to actually apply this plugin to this project, to this root project. I just want to load it so that other sub-projects can just freely use this. If I now hit the Gradle sync here, I expect some issues. And this is because it cannot find the version 8.5.1. We see here something like plugin was not found in any of the following sources, and then it basically tells you that this is not available on Maven Central. What we can do here, or what we should do here, is add the Google repository here as well. We could just add the Google repository here, and we could add it here, and it will definitely make the sync happy and resolving dependencies happy. However, now, since Google is declared as the first repository in this list, Gradle will basically hit it first and ask for every dependency for every plugin if the Google repository contains this particular plugin. And this will lead to a lot of requests that basically just get denied and potentially increase our sync time. What I recommend instead is declaring the repository with a certain Maven content. So we know that we only want to ask the Google repository for anything that is related to Android or Google or Android X. So we can say that this repository should only be asked if we have something that is containing Android as a regex. We also let it be asked for something that is Google. Okay, it also syncs. I will copy and paste this code here as well. And now we should have an optimized declaration. We should now only resolve Android and Google related artifacts from the Google repository. And this potentially just makes the build and initial sync times much faster. Okay, we have declared the Android plugin. We have declared the multi-platform plugin. Now it's time for us to set up our app module, which we also declared here as being included, meaning that we have some module, like Android developers call stuff like this module. The Gradle terminology would be that this is a sub-project. I will continue either module or project because in my heart I'm also still an Android developer somewhat. And I also just use freely those words interchangeably. Now, setting up the app module is as simple as creating the app folder and in there having the build.gradle.kts file declared. Now, since we already told Gradle that we are interested in multi-platform and Android as plugins, we can redeclare or actually now apply these plugins here. Let's resync the ID. It will again give us smart insights. And load the Kotlin Multiplatform plugin as well as the Android, Android, not the library, but the application plugin. We can then, as a next step, after we declared the plugins and applied them, we can now use the plugins in our scripts and get IntelliJ to autocomplete for us. We see that on the bottom right corner, there is already an error message after syncing. It says, please initialize at least one Kotlin target in app. Fair enough. This requires us to declare what kind of targets we want to build for. So in the example here, I want to support JVM as my desktop target. I want to support Android, but I also want to support iOS. So I will go and declare iOS x64, which is the simulator for x64 machines. I will declare support for iOS ARM64, which is the real devices. This is your iPhone. And then we have here the iOS simulator ARM64. I have a M1 Mac, a Mac Studio. So if I want to simulate iOS, I will use the iOS simulator ARM target. We can resync the project and we should now see that everything is fine. We can now use the Kotlin targets here and start building for all of those build targets. As a next step, we want to load the Compose plugins. So there are two Compose plugins. There's the Kotlin Compose plugin and there's the Compose Multiplatform Gradle plugin. The Kotlin Compose plugin is the compiler plugin, which allows the Kotlin compiler to know about composable functions and apply all of its magic. We therefore declare them again here in our root project. So the Compose compiler plugin can also be addressed by using .plugin compose. We want to use the same version as the Kotlin version. Again, use apply false. And we can also load the org.jetbrains.compose plugin. For this demo, I'm using 1.6.11. I again use apply false. And here I can basically copy those plugin declarations over to our app module. I do not need to declare the version again, and I shouldn't. I just reordered those like this. I press sync once again, and we should now have loaded the Compose plugins. Let's now start by writing our first composable function that we can share across all of those platforms. So we can locate the source files under common main Kotlin. Everything that is under common main Kotlin will be compiled for all the platforms. I will not go into much detail on how Kotlin Multiplatform works. I am more focusing on the setting up stuff. So here I'll just use a package like IO Sellmair sample. And in here, I create a composable that I call the main screen, which should just show the main screen of the application. So here, let's select file. I call it main screen. And I will try to add the composable function here. So I go main screen. And I want this to be composable. We see, oh, no. The composable annotation is not auto-completed. We definitely need to start adding dependencies somewhere. The dependencies should be declared mostly on common main. Those dependencies will be available for all platforms. IntelliJ autocomplete is amazing here. It gives us the compose runtime. We can also request the compose foundation. And we can also request material 3 because we are into material, right? Now, after we sync once more, we should expect the composable annotation to be present. And we can hopefully now also just write some kind of text like hello world and make it super big. So we say font size and we just make it really, really big by giving it 42 SP. Next step is writing the Android parts. So I think it makes sense to just start by writing the activity. For this, I'm going to create the activity under the Android main/Kotlin source directory, creating myself a package IO Sellmair app. And I will here use MainActivity as the name of the class. And as you can see, we are now allowed to implement activity. Now, since we want to actually implement an activity that supports Android, we should also declare the Android dependencies. To add the dependencies, we go back to our build.gradle.kts file and we are adding the dependencies to the source set Android main. We are interested in the following dependencies. I will copy them to make it easier and you don't have to watch me typing them out. We are interested in app compat and activity compose in this case. We can sync the IDE. Go back to our main activity and instead implement app compat activity. We want to override the onCreate function and here use the set content to actually use our main screen. Now we can call into this main screen, which is coming from common main, it's shared code, and we should be able to see this main screen, which is supposed to print hello world once we run the app. Let's try to execute the app. We see in the run configuration selector on the top right that we can run the Android app. So let's play it, and we see the emulator starting, but we see that we cannot execute the app so far. There is no compile SDK version provided. So, as you can see, I have not done any configuration for Android so far. So we can add this by opening Android. We want to give it a namespace. So let me select some namespace that is suitable for this example. And autocomplete in IntelliJ already gives me something useful. I want to provide the compile SDK. I want to use the min SDK and the target SDK. And what I also would like to do is provide the application ID. We can resync the project and see if we can now run the app. We see another issue. We see that there is a failure in merging the manifests. So it says that we are using Android X dependencies, but we did not enable Android X in our Gradle properties. So next step here would be to create the Gradle.properties file and set the Android.use Android X to true. Once this is set to true, we can give it a shot. We resync into IntelliJ. We press play. And we see the next failure. We see there is no manifest yet that we created. So we should provide Android with an Android manifest. This can be done by just creating this file under Android main. Note it shouldn't be under Android main Kotlin. It should just be under src Android main. And we can call the file Android manifest.xml. This manifest should look something like this. We define the manifest, we define the application, and for the application we would like to give it a label. So here I will just call it sample CAMP app. And it also makes sense to provide a theme. I select a light, no action bar theme. Then we want to declare the activity. It already auto-completes with the only relevant thing that we can actually use. And for the activity, we also provide an intent filter. The intent filter here is to declare that it should be on the launcher. So once we have the app installed, we see that we can select this from the app launcher and can just use that activity. We therefore need to give it an action, and the action is main. And we need to also select the category. So the category is the launcher. And now we should be able to see that once we have installed the application, it is allowed to just take your phone, go to the app launcher, select the app, and it will launch this main activity. We see one more complaint. We should care about the exported flag here. I'll set this to true. We can resync the IDE once again. We can press play. And we see another issue. Now, this is hopefully the last issue that we have to tackle, but now we see that there is a problem. It says like inconsistent JVM target compatibility. It says something about 1.8 and then 17 here for the Java versions. An easy fix here would be to just select a JVM toolchain that we want to use consistently across the project. I'll select JVM toolchain 17. This is the easiest way of just making sure you have a consistent build. We sync once again. We press play. Hey, and we finally see the Compose app launching on an Android phone. Let's now bring our beautiful app to iOS as well. For this, I'm going to instruct the Kotlin native targets that we have, which already compile the code for us into some klibs, to also provide me some .framework files that I can then later on use in Xcode. For this, I'm going to the Kotlin targets. I'm selecting everything that is a Kotlin native target. I'm configuring this. And here I want to use the binaries DSL to also select a framework. I want then to give this framework a base name. I'm selecting KMP app, and I want to say that this is a static framework. Once we have done this, we can go to the terminal. We can build everything by just executing gradle assemble. We now see a lot of Java long out-of-memory errors, and this is because the default heap size that Gradle is configured with is not necessarily enough to handle many compilations in parallel. You see that for a multi-platform app, if we compile like this, by just like saying compile me everything using the Gradle assemble, we will basically call a lot of tasks in parallel. We will compile a lot of things for every target. We will do a lot of compile steps. We will do the linking. The 500 megabytes, I'm not sure, I think it is 500 megabytes that Gradle is provided with by default, are not necessarily enough to support this many operations at once, so we should increase the Gradle heap size. I'll do this by providing the JVM args directly to Gradle, so I use the Gradle properties file to do this. I'm providing org.gradle.jvm args, and I select -xmx, max heap size, and I think 6 gigabytes on my machine is perfectly fine. I can resync here. Once again, execute Gradle assemble after the sync has finished, and then we should see the final compilation. That being said, let's start Xcode up and create the project. I will now select create new project. I will use app for iOS. As a product name, I also call it KMP app. I select the team, and I press next. For the location, I think this one here, we created under JetBrains projects, KMP app. So I select this one, I go here into the iOS app. I'm creating myself a new folder called iOS app. And I select this as my location to put the app in. Once Xcode started up, we want to start configuring it in a way that it compiles the Kotlin code as well. And we should compile the Kotlin code before we compile the Swift code. We want Kotlin compiler to produce the framework, which we then can reuse in our Swift code to actually run the app. For this, we go to this KMM app, we select the build phases, and we want to create a new run script phase. We put this run script phase above the compiled sources because, again, we first want Kotlin compiler to produce the framework. Then we want to use this framework from the Swift compiler and then build our final app. I will call this run script phase here, compile Kotlin. And in order to invoke the Kotlin compiler, we can go back to our original project here, and we see that KM app here from iOS is located at least 3 levels up from this root project, which contains this Gradle wrapper file. And we want to execute this Gradle wrapper so that this Gradle wrapper will produce us the framework and recompile the frameworks if needed, that we can see here in bin iOS simulator ARM, for example. And then we see here the release framework. Going back to Xcode, when we want to create this script, we first want to change the directory so we are nearby this Gradle wrapper. So I change this and I will use the $src root, the source root variable, which is a placeholder for the location of the current project. And then I will go 3 levels up. And this will allow me to invoke the Gradle wrapper here. And I want to invoke or compile the app module. And I'm copy pasting now the name of the task. It is embed and sign Apple framework for Xcode. What this task will do is it will read the current environment variables that are set up by Xcode, and it will know which exact framework it should compile for Xcode at this very moment. So if you select your simulator, it will compile the simulator ARM64 framework. If you want to ship the app on your device, it will automatically know that it should compile the framework for the iOS ARM64 architecture. We can now press this play button here to start our script and start compiling our frameworks. If we look into the build output here, we can see that there is some issue. It says like execution task, for task, app check, sandbox, and write protection failed. And it says you have sandboxing for user scripts enabled to make the embed and sign Apple framework for Xcode task pass. Disable this feature. Sounds like an easy instruction for me. We can go to the build settings, search for sandboxing, and just disable the user script sandboxing. Once this is disabled, we can go back to our original project. We can quickly make sure that we stop any Gradle daemon that is currently running so that this sandboxing change in the environment is picked up by Gradle here. We press play once more, and we should now see that it starts actually compiling our framework. Yep, the build is successful, and it wants to launch it even on my phone. Now that we have configured Xcode to actually invoke the Kotlin compiler during its build, we now also need to tell it where to find or look for the frameworks. For this, we can go to the KMP app here. We can look for the framework search path in the build settings. And we should see here search paths. We see the framework search paths, and we will add the corresponding folders here. We will again use the SSC root variable to reference the location of the current project. So SSC root, from there we want to go up twice. Then we want to go into the build /Xcode frameworks. Then we want to use two more variables in this case. We want to see that this is located under the current configuration. And then Gradle will put it under the current SDK name. We hit enter, and now it should automatically, for our configuration here, select the corresponding search paths. Let me select a simulator here. I'll use this iPhone 15 simulator, and as you can see, the simulator showed up. Now, since we have connected Xcode to our Gradle project, and we are able from within Xcode to invoke our Kotlin compiler, building us our framework, it is time to actually write some code for iOS. We want to have some kind of ViewController that we can then reuse from our Swift code to actually show something on the screen. For this, we can use iOS main/Kotlin and put our source code in there. I'm using the same package as previously, which is io Sellmair sample. And in here, we'll create a new sample KMP ViewController. Now this will be a function. We call it as well sample KMP ViewController. And it represents a compose UI ViewController. Inside this compose UI ViewController, we can now use composable functions. We can use the main screen to show our app. It is fair to suppress the unused warning from IntelliJ. We know that this will only be used from Swift code, so I am selecting suppress for this function, and I will add the comment used by Swift. If we go back to Xcode, we should now be able to use this ViewController and present it on screen. For this, I'm going to provide a struct. I'll call it compose view. And this will be an UI ViewController presentable. I'm implementing the make UI ViewController function. And in here, now the magic should happen. I should now be able to use the sample ViewController KT, sample ViewController. I could also just call this function create. I can return this. And I also need to implement the update UI ViewController function. I don't need to do anything here. And now instead of showing this VStack and padding this hello world code, I could just show the compose view instead. We can hit run. And we see also our hello world from Kotlin showing up. The last target that we have not yet cared about is actually bringing this app to the desktop as well. For this, I am adding a dependency to the JVM source set, so sets.jvm main dependencies, and I want to have the compose desktop current OS available on our JVM main source set. From there, I'm creating the source files under JVM main/Kotlin. I'm again creating the same package, io Sellmair.sample. I can now create a main file, so I call it main, function main, and now I have to just start the application. We have a nice application function for you that you can just call into. We need to provide a window. We can give this window a title. We call it PMP demo or sample. Like, we need to provide what should happen if there's a close request. We exit the application, and inside this window we show also the main screen. Now let's just press this run gutter, and also the desktop app is shown. So to reiterate, we have now the simulator showing us hello world. We have the desktop app showing us hello world, and we should see an emulator from Android as well. That's it. We have built a multi-platform application that targets iOS, desktop, and Android. I will maintain a GitHub repository that contains all the necessary steps as commits in the master or main branch. So you can check each individual step out in the GitHub repository. Also, I should be able to provide a nice blog post that also describes every step. That's it. Simple, isn't it?